my young friends, beloved students. Welcome back to C-Level Physics. My name is Srinivas. Today we are going to discuss the relation between maximum height and horizontal range. Okay. Now what are the expressions for height and range in case of projectile? That is h equal to u square sin square theta by 2g. Otherwise u square sin square theta means u sin theta whole square. That is u sin theta means uy. So uy square by 2g. So what about maximum horizontal range? That is range equal to u square sin 2 theta by g. U square sin 2 theta by g. Right? That is also can be written as twice ux uy by g also, where ux means u cos theta. Am I right? Ux means u cos theta. Uy means u sin theta. Right? Okay. So h is so and so, range is so and so. These are what general expressions in case of oblique projectile. Right? Now r by h implies that. What is r? R means take this term twice ux uy by g. R into 1 by h. R by h means r into 1 by h. H means what? This is h. 1 by h means 2g by, see here, 2g divided by uy square. Uy square. Okay. That is uy cancel. We left with one more uy. Here g cancel. So r by h equal to 2 4. That is ux by uy. Ux by uy. That is 4 into ux means what? U cos theta. Okay. U cos theta. Divided by uy means u sin theta. Alright? That is u cancel. Cos theta by sin theta. That is cot theta. So r by h equal to 4 cot theta. R by h equal to 4 cot theta implies r equal to 4h cot theta. This is the required relation. Okay. R equal to 4h cot theta. Right? Suppose if theta equal to 45 degrees. Right? If theta is 45 degrees. Now r equal to 4h cot theta. Theta means angular projection, that is 45 degrees. R equal to 4h cot 45. Cot 45 means 1. That is r equal to 4 times maximum. So when it possible means when angular projection is 45 above the ground, then range becomes equal to 4 times maximum height. See here. This is the oblique projectile with angular projection is theta, that is 45 degrees. Now this is what in fact maximum height. Now this is what range. Right? See, path OAB. Right? Now this is what OB is range. Range equal to 4 times maximum height. 4 times maximum height. When it possible, when angular projection is 45 degrees. Okay. Right? If at all, next point, if r equal to, see here, r equal to 4h cot theta. Am I right? R equal to 4h cot theta. Okay. Suppose r equal to 4 times n times h. If r equal to n times h, that is n may be 1, 2, 3 up to so on. If r equal to n times h and maybe any integer, then what happens? We know that relation r equal to 4h cot theta. That is, we know that r equal to 4h cot theta. Now replace r means n times h. N times h equal to 4h cot theta. Now h cancel. Right? That is cot theta, make it subject n by 4, otherwise n by 4 equal to cot theta, right? N by 4 equal to cot theta implies tan theta equal to 4 by n. I'm taking cot theta this side, that is becomes tan theta. Tan theta equal to 4 by n. Now theta equal to tan inverse 4 by n, right? Theta equal to tan inverse 4 by n. If at all n equal to 5, suppose r equal, otherwise n equal to 3 here, for example. If n equal to 3, then theta equal to angular projection, theta equal to tan inverse 4 by 3. Angular projection theta equal to tan inverse 4 by 3. So that's how one can find angular projection even from relation between r and h. If you are given r equal to so and so times h, here so and so means n may be any integer. Am I right? Now based on this explanation, let us see one numerical. Suppose one body is projected with an angle of projection theta, the horizontal, as shown. See here. Suppose this one on projectile. See one numerical, right? This one on projectile, which is projected with some initial velocity such that making an angle theta with horizontal. Now definitely it takes parabolic path. Why? Because it is subjected to gravity. There is no other force except gravity. So definitely it takes parabolic path as follows. Right? Okay. Now the question is, when it reaches highest point A, see path OAB is parabolic path. When it reaches highest point A, right? What are the coordinates here? See here. Now here r comma 0. What is horizontal component here from O to B? What is the horizontal distance covered? Range. Here vertical displacement covered on reaching B means 0. When it lies at A, highest point, what are the coordinates? See, this is what? R by 2. Why? Because total distance along OB, R, means this is a symmetrical parabola. So therefore this is what half of the distance, that is R by 2. So this distance also R by 2. Now total OB equal R by 2 plus R by 2, that is R. Okay. Now here, what is this vertical height? That is maximum height H. Right? Now here coordinate, x coordinate R by 2, y coordinate H. Right? Y coordinate H. Right? So we can represent coordinates like. Now the question is, on reaching highest point A, angle of elevation. What is the angle of elevation? Phi. Angle of elevation is phi. See here pi and theta are not same. Theta means angular projection. Here pi means angle made by position vector or displacement vector at a given position on the trajectory with the horizontal. See, when it reaches at highest point, see this is what displacement vector. OA bar is the displacement, otherwise position vector, which makes an angle pi with the horizontal. Now the question is, relate pi and theta. Find the relation. Find the relation between pi and theta. Between pi and theta, where pi means angle of projection. Angle of elevation. Theta means angle of projection. Right? How to solve here? How to solve? See, this is what right angle triangle. So this opposite side, this is adjacent side. Opposite side means H. Adjacent side means R by 2. So take tan pi equal to H by R by 2. H by R by 2. Alright, tan pi equal opposite side by adjacent side. That is, tan pi becomes equal to twice H by R. Twice H by R. Now what is the relation between H and R? R equal to 4H cot theta. Am I right? So replace here. So tan pi equal to twice H by R means what? 4H cot theta. 4H cot theta. R means 4h cot theta from this relation. Now h cancel. We left with 2 by 4 means 1 by 2. 1 by cot theta means tan theta. Tan theta. Left side tan pi. So tan pi equal to half of tan theta. So most important relation. What is this relation? In case of oblique projectile, the time when it reaches highest point, the relation between angle of elevation and angle of projection, that is tan of angle of elevation equal to half of tan of angle of projection. That's what required relation. Okay. Now we have to prove the path of projectile is a parabola, right? Now see, let us see. So we are going to prove path of oblique projectile as parabola, right? So parabola means either y square is proportional to 4ax, otherwise x square is proportional to 4a1, whatever it is, right? So here we need to prove path to be parabola. In case of body projected, some angle theta with horizontal, right? See, the next point, path of oblique projectile as parabola. So this is the statement. Okay. Now see, here body is projected like that. Some initial velocity u, such that making an angle theta with horizontal. Right? Now here, what is the path taken by the body here? Parabola line. Right? This is the path followed by body. Now here I am taking 3 points on the path. O, highest point A, point at which lands on the ground, that is P. That is P. Right? This is what y-axis. Y-axis. This is what x-axis. Okay. Now let me say that at a given instant T, let P be the position of the particle. Here let P be the P x comma y be the position coordinates for the given projected object. See here after projection at a given instant T, it reaches position P with position coordinates x comma y. X comma y. With the position coordinates x comma y. It reaches this position by that time. Okay. Now the position coordinates saying that the horizontal displacement covered by the projectile is x. See here, if I close like that with one normal onto x-axis. Now this coordinate, this is what vertical displacement covered by the particle, that is what y. So this is what y. Now this is what horizontal displacement covered, that is x. Alright. So when it reaches position P on the trajectory, let x and y be the position coordinates of the projectile. Means horizontal displacement covered is x units, vertical displacement covered is y units. Okay. Why? Because simultaneously it possesses horizontal as well as vertical velocities. Accordingly, it possesses it covers horizontal and vertical displacements. Okay. Now, as usual, as u is making some angle with horizontal, it can resolve into two components. Along horizontal ux, that is u cos theta. Along vertical, what is that? Uy, that is u sin theta. So these are nothing but the components for velocity projection. Am I right? Now I am taking s equal ut plus of h square along horizontal as well as vertical. First of all, along horizontal, right? What is the expression? S equal to ut plus of a is. That is sx uxt plus of ax is. Right? Here, what are the components for acceleration here? See, body is acted upon by gravity, that is always vertically downwards. Right? So here, ay acceleration along y-axis, that is minus g. In fact, g, but as per sign convention, minus g. Why? Because it is pulled by, body is pulled by earth downwards. So gravity, otherwise gravitational force is downwards. Accordingly, g downwards. Downwards in the sense towards negative axis. That's why minus g. Right? Now what about horizontal acceleration? Ax equal to 0. Why? Because there is no force along horizontal. Along horizontal there is no gravitational force. Otherwise no other force. So therefore definitely acceleration in that particular direction is 0. Okay, whatever the acceleration possessed by the projectile, that entirely acting downwards, that is minus h. Now sx means what? X. Horizontal displacement x. That is x equal to ux means u cos theta into t. What is the time taken by the projectile to reach p? Means t after projection. Plus half into x means 0 from that point, that is t square. That is x equal to what? uxt. Right? Implies t equal to x by ux. That is x by ux means what? Ux, u cos theta, means horizontal component for this initial velocity of projection, right? Okay, that is u cos theta. U cos theta. Number 1. Okay, similarly, I have to consider the same expression along y-axis. Why? Because it possesses or it covers vertical displacement also by that time, right? So along vertical direction, take the same expression, that is s equal to ut plus of ax. That is sy equal to uit plus of ay t square, right? Sy equal to uit plus of ay t square. That is, sy means what? When it reaches position p, what is the vertical displacement covered? Y units, that is y. So sy means y equal to u sin theta, otherwise uy to t plus half into ay means what? Ay minus g into t square. That is y equal to uit minus half g square. That is y equal to uy means what? Uy. Initial velocity along vertical, that is u sin theta. Otherwise uy. Okay. Uy into t means what? See here, t means in terms of horizontal component of velocity, that is t equal to x by ux. That is x by ux plus or minus of g into t square. What is t here? Again, t means x by ux, otherwise x by u cos theta. X by ux whole square. X by ux whole square. Right? Okay, that is y equal to uy by ux. Uy means u sin theta, ux means u cos theta. That is u sin theta by u cos theta into x minus g by 2 into here ux square. On squaring, here x square is there. X square, g x square by 2 into ux square. Ux means what? U cos theta. That is u cos theta whole square. U cos theta whole square. Right? Okay, that is u square cos square theta on squaring. So u cancel here. Y equal to sin theta by cos theta means tan theta. Tan theta into x minus g by 2 u cos theta whole square, that is u square cos square into x square. Am I right? So we left with y equal to tan theta x minus g by 2 u square cos square theta into x square. Okay. Here theta means angular projection at O. So tan theta means, as theta is constant, angular projection is constant at O, implies that tan theta also constant, right? So say tan theta like A, some constant A. Next, G at a given place, G is constant. U cos theta, otherwise U square cos square theta, constant. Two straight away constants. So therefore this term also constant. This entire term is some other constant. What is that constant? B. Here it is A, here it is B. Now x and y. What are the x and y here? X, y means variables, positional coordinates. As particle moves along the parabolic path, both x and y changes with time individually. So x, y are variables, but tan theta, g by 2 square cos square theta are constants. So replace y becomes equal to ax minus bx square. Ax minus bx square. So this is what parabola, inverted parabola. Inverted parabola, right? See, y equal to x minus bx square is inverted parabolic equation. So, is it path or not? Check once. What is meant by equation of trajectory? Suppose if x is a function of time, if x is function of time, y also function of time, right? If y and x are related such that t is eliminated, then y equal f of x is nothing but equation of trajectory. Am I right? See here, individually x is a function of time, y also function of time. See here, y also function of time, but here y and x are related. Y equal to tan theta x minus g by 2 square cos square theta into x square. Is there any time here in the expression? No, there is no time here in the expression. Here also y equal to ax minus bx square. Simply this is the relation between x positional coordinate and y positional coordinate without involvement of time. Of course, individually both x and y are dependent on time individual, but here y and x are related without taking any term time. Okay, so therefore nothing but the equation of trajectory, right? So if x and y positional coordinates are related to each other without any involvement of time, then that expression is said to be equation of trajectory. So here it is equation of trajectory. Am I right? Okay. So what is the shape of mathematical equation here? Inverted parabola. See, this is what inverted parabola. Inverted parabola, right? Now on extending here, y equal to, what are the expressions for y? Y equal to tan theta x minus g by 2 square cos square theta into x square. Let us see some other forms from this relation. Already we have two relations. Here g by 2 square into 1 by cos square theta means secant square theta. So that also one of the forms for the equation of trajectory of oblique projectile, right? Now see, you can write in different forms for the same equation, right? Okay. Different forms of equation. First one. What is the first one? Y equal to tan theta x minus g by 2 u square cos square theta into x square. This is what the relation what we acquired here on simplification, right? Y equal to tan theta x minus g by 2 square cos square theta into x square. Same can be written as y also equal to tan theta into x minus g by 2 u square. 1 by cos square theta means secant square theta into x square, right? What is the other form here? Y equal to ax minus bx square. See, here it is a. Tan theta means what? That is a. G by 2 square cos square theta means that is b. Right? So ab minus bx square. That is ax minus bx square. Another form, ax minus bx square. Right? So number 1, different forms, number 1, number 2, number 3. Right? Now we are going to extend this relation to have another form also. This one. Okay. What is that form? See here. On extending first expression, see implies, first one implies y equal to, see here tan theta x is kept common, that is x tan theta. Tan theta x means x tan theta is kept outside, that is 1 minus. It is kept common, that is 1 minus g by we left with 2 u square cos square theta into tan theta is kept common, so we have to divide here 1 by tan theta, that is 1 by tan theta, 1 by tan theta into x square is there, but one x is kept outside, so we left with one more x, that is x by tan theta, right? So when tan theta x is kept outside, that is we left with inside 1 minus g by 2 square cos square theta into x by tan theta. Or extending, what will get means that is y equal to x tan theta into 1 minus g by 2u square cos square theta into tan theta means sin theta by cos theta. That is sin theta by cos theta. Here denominator x is there, right? That is y can be written as x tan theta 1 minus, here cos theta, 1 cos theta cancel. We left with cos theta here, that is g by 2 into u square is there, so u cos theta into u sin theta, u cos theta into u sin theta into x. See once again, so 2 u square is there, no? Here cos theta cancel, we left with 1 cos theta, that is 2 into u square is there, so u cos theta into u sin theta by g. That is y can be written as x tan theta 1 minus, see here x by 2 into u cos theta into u sin theta. G is there, no? Take to this denominator by g, right? That is x tan theta 1 minus x by, take this g onto denominator, that is x by 2u cos theta into u sin theta by g, nothing but 2ux uy by g means range. So y equal to x tan theta 1 minus x by, what is this expression? 2ux uy by g, that is 2 u cos theta u sin theta by g. It is range x by r, right? So this is one more relation. So what is the fourth formula here? Y can be written as x tan theta of 1 minus x by r. See, in any expression there is no term t. T means time. See here, this is the relation between x and y positional coordinates. Here also relation between x and y positional coordinates. Here also same. So in any of these expressions, can you find the term t means time? No, there is no involvement of time in all these expressions. Simply that the term time is eliminated. Then only we can say that is the equation of trajectory for the particle which is under motion, right? it is projectile. So y equal x tan theta 1 minus x by r. 1 minus x by r. This is the derivation. Alright. So on extending this one like this, we'll get y equal x tan theta 1 minus x by r also. Now based on these expressions, suppose we are given any relation. Now we can compare suitable one of these suitable general equations of trajectory such that to find or so that to find unknown quantity. Right, unknown quantity. On comparing any one of these suitable equation of trajectory in case of oblique projectile, one can find unknown quantities also. Right. Now let us see one numerical based on this expression. Fourth expression. Right. Okay. Fourth one. What is the numerical here? See, one numerical. Here one body is projected with some unknown velocity at some unknown angular projection with the horizontal, like this. See, this is what velocity of projection unknown. Here, what is angular projection theta, which is also unknown, right? So here one body is projected at some unknown angle theta with the horizontal with some unknown velocity. Now usually it takes parabolic path, right? Parabolic path. Okay. So during its motion, it just clears one wall like that. See, this is what wall. This is what wall. Wall. Okay. This is what wall of height 3 meters, which is at a distance of 6 meters from the point of projection. 6 meters from the point of projection. Just clears. Here the projectile just clears a wall of 3 meter height, which is at a distance of 6 meters from the point of projection, and lands at a distance of 18 meter behind the wall. See here, it lands at some place here which is at a distance of 18 meter away from the wall. So on adding these two, 6 meter plus 18 meter, what will you get? Range, usually range, right? See, what are the points, usual points O? Here it is A, highest point, it is B. Now what is horizontal displacement or horizontal distance in the entire path? That is OB means 6 meter plus 8 meter, range. Usually that is range. Now can you take height of the tower as maximum height? No, you are not supposed to take a given height of wall as maximum height. Why? Because unless or until mentioned in the sum, you are not supposed to take the height as maximum, height of the wall as maximum height. Right? Simply, this is what y coordinate, this is what x coordinate. So, what are the coordinates for this position? See, for this position coordinates p, x comma y. X means 6, y means 3. So 6 comma 3. 6 comma 3. Simply those are positional coordinates. You are not supposed to consider 3 meter as maximum height unless or until it is mentioned in the given sum. Okay. Now x coordinate 6 meter, y coordinate 3 meters. Now the question is, what is the angular projection? What is the angular projection? What is the angle of projection? What is the angle of projection? Now how to solve? See, we have relation. Y equal x tan theta 1 minus x by r. So r also known. Why? Because 6 plus 18 means r. So r known quantity. X that is 6 meters. Y that is 3 meters. Now tan theta known. Can you find? Yes. Very simple. So range means here what? Range means 6 meter plus 18 meter. That is 6 plus 18. That is 24 meter. Now x comma y. X comma y means 6 comma 3. Now take this formula. Why? Because except tan theta, all are known quantities only. So better to consider this form, right? That is y equal to, we know that x tan theta of 1 minus x by r. 1 minus x by r. That is, y means what? 3. X means what? 6. Tan theta unknown. 1 minus x by r. That is 6 by r means 24. That is 3 by 6 equal to tan theta of 6 by 24. 1 by 4. 1 minus 1 by 4. That is 3 by 4. Right? 3 cancel. We left with the tan theta equal to 4 by 6, which is equal to 2 by 3. Implies theta equal to tan inverse 2 by 3. Tan inverse 2 by 3. Theta equal to tan inverse 2 by 3. So that's how one can find angular projection. Right? Okay. Now let us see one more numerical. This time, one more numerical. Okay. See, here one more numerical. What is that? So same projectile, oblique projectile like that. Oblique projectile like that. So the last projection view, angular projection theta, angular projection theta. Right? Suppose during its motion, let p x comma y be the position somewhere here. P x comma y here. Right? Now I am joining position of the particle by the time when it reaches P with the point of projection, right? So this is what position vector or a displacement vector when particle reaches point of projection, or when particle reaches some point P of x comma y, right? So here angle made by position vector with horizontal at the alpha. Now suppose this is what point at which it lands on the ground. I am taking one more line from P to this point at which it lands like that. Like that. Now what is this angle? Beta. Right? Now position coordinates is what? Beta. Is what? Beta. Right? Suppose if I take one normal onto x-axis, this is what? Y-axis. This is what? Y-axis. Y-axis. This is what? X-axis. Right? Now say P x comma y is the position of the particle at a given instant. Okay. Now what is this distance here? This distance is x. This is what? X. X. Right? This is what? R minus x. Why? Because total horizontal distance covered is r. From here to there x. Now rest of the distance, total range minus x. That is r minus x. Why? Because here coordinates. What are the coordinates? X coordinate here range. Y coordinate 0. So total distance is range. From here to there x. Now rest of the distance r minus x. Okay. Now the question is tan alpha plus tan beta is what? Find the value of tan alpha plus tan alpha plus tan beta is unknown. See one more time here. Here one particle is projected with some unknown initial velocity such that making an angle, unknown angle theta with horizontal, right? Now during its motion, it reaches the position P x comma y. Now what are the angles? What are the angles made by position vector with P means alpha, right? With B means beta from the point. So tan alpha plus tan beta is question mark, right? Now what is the relation here? Y equal x tan theta of 1 minus x by r. We have one relation, right? So here theta means angular projection. Positional coordinates of x comma y. So therefore 4 implies fourth expression. See, fourth, you know that fourth expression y equal to x tan theta of 1 minus x by r. Am I right? Yes. Okay. That is y equal to x tan theta of r minus x by r. I am taking LCM. Right. I am taking tan theta. So make it subject tan theta. That is tan theta equal to y into r by x into r minus x. Number 1. Alright. So make it subject tan theta y or by x into r minus x. That is tan theta. Right. Now similarly here, take tan alpha. Now what is this vertical displacement y coordinate? That is y. This is what y. This is what x. Horizontal displacement is x. Vertical displacement is y. And it reaches position P. So tan alpha. From the diagram, take tan alpha equal to what is tan alpha? Y by x, opposite side by adjacent side, that is y by x. So tan alpha means y by x. Similarly take tan beta equal to y by r minus x. See, opposite side by adjacent side, beta is somewhere here. So this becomes opposite, this becomes adjacent. So tan beta equal to y by r minus x. Now take the sum, find the value of tan alpha plus tan beta. Now I am taking tan alpha plus tan beta, that is y by x plus y by r minus x. That is tan alpha plus tan beta equal to, take LCM, x into r minus x. That is y into r minus x plus y into x. That is y r minus y x plus y x by x into r minus x. Right? X into r minus x. So y r minus y x plus y x. So these two terms cancel. One with negative sign, another one with positive sign. So we left with y r by x into r minus x. Now what is y r by x into r minus x? See here, since from 1 that becomes equal to tan theta. So we can write it as tan theta, that is tan alpha tan beta equal tan alpha plus tan beta equal to tan alpha plus tan beta equal to tan of angle of projection. Okay, tan of angle of projection. Right? So that's how one can find relation between alpha, beta and theta. Right? Okay. Now let us see one more final sum in the same way. Suppose here, this time you are given two positions at two different instants. Two positions at two different instants. Right? Here it is A comma B. Here it is B comma A. Say this is what point P1, this is what point P2. Right? So here once again, the body is projected with some unknown velocity u such that making an angle theta with the horizontal as shown. Now during its motion, you are given two positions at two different instants with the position coordinates a comma b and b comma a respectively. We are not saying that these are at same level. Of course, both are at different levels. Okay, both are at different positions also, different positions as well as different instants. Right? Okay. Now the question is, find the value of range. Find range. Otherwise, find range and angle of projection. So for this case, we need to find range, horizontal range and angle of projection. Okay, horizontal range and angle of projection. So you can follow like this. For position P1, take the same relation. We know that y equal to x tan theta of 1 minus x by r. Y equal to x tan theta of 1 minus x by r. See, for position P, what is x A? What is y B? So x means A, y means B. So y means B. B equal to A tan theta of 1 minus A by r. Number 1. Similarly, see here x means A, y means B. Y means B, x means A. Okay. Similarly, take the same relation even at position P2 also. Okay. This time x means B, y means A. So A equal to B tan theta of 1 minus x. X means B. B by R. Alright. Number 2. Y means A. Right, x means B of tan theta into 1 minus x by r, that is B by r. Right, now take the ratio 1 by 2 implies B by A equal to tan theta by tan theta cancel, we left with A by B into here LCM r cancel, here numerator r minus A by here numerator r minus B. Right. Now B into B square equal to A into A square into R minus A by R minus B. R minus A by R minus B. Right? Okay. That is, take cross multiplication here. B square R minus B square into B cube equal to A square R minus A square into A. That is A. Right? Okay, B square R minus B cube equal to A square R minus A. Now take this A cube this side, that is A cube minus B cube equal to A square minus B square into R. Right? See here R is common, A square minus B square. Here A cube minus B cube. Like that. Now make it subject to R, that is R equal to just formula A cube minus B cube by A square minus B square. Okay, this is R. Range equal A cube minus B cube by A square minus B square. We can extend like that. A cube minus B cube means A square plus AB plus B square into A minus B divided by A square minus B square means A minus B into A plus B, that is A minus B into A plus B. A minus B cancel. We left with R equal to A square plus AB. See here AB plus B square by A plus B. A plus B. You can take this formula also. So R either A cube minus B cube by A square minus B square, otherwise A square plus AB plus B square by A plus B. Right? So we have found value of range. Now what about angle of projection? See here, angle of projection means we can extend any one of these two expressions by replacing R value. R means take this formula. So 1 implies, what is 1? 1 implies, see here, 1 implies B equal to A tan theta of 1 minus A by R. A into A by R means A into 1 by R. A into 1 by R. 1 by R means take the reciprocal here. That is A plus B by A square plus AB plus B square. That's all. Now extend. So B equal to A tan theta of, take LCM, 1 into this one. That is A square plus AB plus B square minus A into A square minus or plus minus A into B by LCM A square plus AB plus B square. right? That is plus AB minus AB cancel. Plus A square minus A square also cancel. We left with here B square means 1B cancel, right? So we left with 1 into this one, that is 1 into this one, A square plus AB plus B square equal to, we left with here. So AB cancel, A square cancel, B square cancel, A square cancel. Here one B is there. B is there here. B square means we left with B. So these two cancel. These two cancel. Here one B is left. So B into A. That is AB tan theta. AB tan theta. That is theta equal to tan inverse of A square plus AB plus B square by AB. This is what? Angle of projection. Angle of projection. Okay friends, with this I am concluding. Thanks for watching. I request all the audience to please subscribe channel C Level Physics. Thanks a lot.